Hello, it's Kev Randall here with more help for your OCR Core 1 exams. This is the OCR June 2007 Core 1 paper. It's question 5. It's a differentiation question. It's based on a problem where you have to calculate maximum values and work out the maximum area of an enclosed space. So, just look at the question. It's a question worthy spending some time on because this kind of question comes up quite regularly. The diagram shows a rectangular enclosure with a wall forming one side and the wall in red there. A rope of 20 metres is used to form, 20 metres length is used to form 3 remaining sides, and the width is X metres. So I've marked X on that diagram there. Questions first of all show that the enclosed area is given by A equals 20x minus 2x squared. And secondly, for 4 marks, we have to use differentiation to find the maximum value of A. Maximum value of the area, that is. So, where do we start? Well, we need to calculate, to find the area, we know that's X metres, so we need to calculate this distance here. Well, we know if the length of the rope is, this is for question part 1, we know if the length of the rope is 20 metres, and this distance here is X, therefore this distance here is X, then this distance here is 20 metres, which is the length of the rope, minus 2x. Actually, you get 1 mark just for saying that. Now we can reason then that the area then is going to be this length times that width. So the area is going to be X, the width there, times 20 minus 2x, and that gives us x times 20 is 20x, x times minus 2x is minus 2x squared. So that's the area. If you look at the question again, show that the enclosed area is given by 20x minus 2x squared. We've done that, that's good, so we'll get 2 marks for that. Part 2 says use differentiation to find the maximum values of A. So for part 2, well, where does differentiation come into it? Well, the area varies with the value of X. Yeah. As X changes, so the area changes. When we've got a maximum value for the area, then the gradient of the curve is going to be 0. So first of all, we need to find an expression for the gradient of the curve. Now if we've got A equals 20x minus 2x squared, which we've established there, then we can say the dx equals 20 minus 2 times 2 is 4x. And we do get a mark for that. Now, when the curve is at a maximum, I'll just go up here and just sketch this curve. If we've got, there we've got x, and there, up there we've got the area. When the curve is at a maximum like that, then the gradient is equal to 0. So the gradient is there, is equal to 0. So we can say at maximum A, which is this point here I've just identified, then the A by dx equals 0. So 20 minus 4x equals 0, which means for x equals 20, which means x equals 5. And we get another mark for that. So now we've found x. For the maximum area, we've found x, which is 5. So all we need to do is find the length here, there, multiply them together and we find the area. So we've got x equals 5. The length, well, we know the length of the road is 20 metres. So the length we're looking for is 20 minus 2x. Just check the diagram again there. It's 20 there, minus x minus 2x. So we've already worked out that x is 5 there. So 20 minus 2x is 20 minus 10, which equals 10. So there we've got on our diagram, just to reproduce it there, we've got that's 5 and that's 10. So the maximum area equals 10 times 5, which equals 50 metres squared. And for that we get another 4 marks. So got that right, got that right, so we've got a total of 6 marks for that question on differentiation.